Polaris, also known as the North Star, has long been a dependable fixture in our night sky, guiding sailors, astronomers, and explorers with its unwavering presence. However, recent scientific observations suggest that this iconic star may be on the brink of a dramatic transformation, potentially altering our night sky forever. Polaris is part of a triple star system and is classified as a Cepheid variable star, meaning its brightness pulses in regular patterns. However, astronomers have noted irregularities in these pulsations, leading some to speculate that Polaris could be nearing the end of its life. Situated approximately 323 light-years away from Earth, Polaris has played a crucial role in navigation and astronomy due to its near-fixed position above Earth's northern axis. Historically, its reliability has made it a symbol of constancy, but this stability may soon be disrupted. In September 2023, a research paper presented by the Royal Astronomical Society raised concerns about the star's fate, suggesting that Polaris may explode in a supernova. Though any explosion that occurs would not be visible to us for hundreds of years due to the star's distance, the light from such an event could outshine the moon and remain visible for weeks or months. The pulsation period of Polaris, which was once stable, has recently begun to increase. While some astronomers attribute this change to interactions within its star system, others fear it signals the star's impending demise. Polaris shares these irregularities with another famous star, Betelgeuse in the Orion constellation, which has also shown signs of instability and is expected to explode at some point in the distant future. While both stars are massive and at a late stage in their life cycles, the exact timing of their potential supernovae remains uncertain. If Polaris were to explode, the event would not pose any danger to Earth, but it would significantly alter our perception of the northern night sky. The star's familiar position as the anchor of constellations like Ursa Minor would be lost, and new navigational methods might need to be developed. While Polaris' fate is not yet sealed, the growing evidence of its instability has astronomers worldwide closely monitoring its behavior. An eclipse occurring near a star would undoubtedly capture the attention of cosmologists, observatories, and the broader academic and astronomical communities. However, its specific impact on Earth's environment or surroundings would likely be less significant compared to a closer supernova event. That said, what about Polaris itself? What is its ultimate fate after a potential supernova? Let's clarify a few things first. While massive stars often end their lives in a supernova, this is unlikely for Polaris. When a massive star undergoes a supernova, it marks the final cataclysmic phase in its life, triggered by the collapse of its core and the ensuing shockwave that causes the star to explode violently. However, Polaris isn't massive enough to experience such an event. Instead, once Polaris exhausts its nuclear fuel, it will shed its outer layers and transition into a white dwarf. This transformation won't lead to a supernova but rather to a quiet end, where it becomes a small, dense stellar remnant. A white dwarf is the remnant of a low or medium-mass star that has depleted its nuclear fuel, compacted to the size of Earth while still containing mass similar to the Sun. Once this happens, Polaris will no longer be visible from our planet, much like other stars that have completed this phase of their life cycle. By examining historical supernova events, astronomers gain significant insight into the life cycles and ultimate fates of stars. For example, SN 1987A, SN 2011 Fe, and SN 2014J have provided valuable data on the aftermath of stellar explosions. SN 1054, which led to the formation of the Crab Nebula, still offers astronomers a rich field for study as it continues to expand and emit radiation across multiple wavelengths. Similarly, SN 1987A, observed in the Large Magellanic Cloud, offered insights into nucleosynthesis and the dynamics of supernova remnants. Exploring phenomena such as nebula formation, the release of cosmic rays, and variations in luminosity can shed light on Polaris's unique characteristics. When stars explode in supernovae, they eject material that interacts with the surrounding interstellar gas and dust, enriching it with heavy elements. This contributes to the cycle of stellar birth and death. The release of cosmic rays, which are high-energy particles accelerated by supernova shockwaves, has implications for astrophysical processes and cosmic radiation conditions. To make a conclusive comparison, researchers evaluate differences in the mass, composition, and velocity of ejected materials between potential future events like Polaris's transformation and those already observed. This involves studying the light curves, spectra, and remnants of supernovae, projecting similar characteristics for Polaris's potential transition. Researchers also assess whether Polaris's evolution could lead to the formation of nebulae or specific elemental distributions, which could enhance our understanding of its possible outcomes. Another important area of research involves the pulsational variability of stars nearing the end stages of their lives, much like Polaris. Comparing this variability to observed supernova progenitors can help identify similarities or deviations, providing insight into the mechanisms driving stellar death. The pulsational variability in stars approaching the end of their lives may be indicative of internal instabilities or imminent catastrophic events, offering clues to the evolutionary processes that lead to supernova explosions. Despite careful observations and extensive study, astronomers are often surprised by the irregularities observed in Polaris's behavior. Understanding the unique conditions driving these irregularities is key to advancing our knowledge of stellar evolution. Unraveling the mechanisms behind Polaris's peculiar pulsations will require interdisciplinary collaboration, the development of advanced theoretical models, and innovative observational techniques. The potential disappearance of Polaris, a key reference point in the night sky, presents significant concerns for astronomical endeavors. Ground-based telescopes and celestial measurements would require recalibration, affecting the precision of astronomical evaluations. The absence of Polaris could also impact navigation systems and cultural practices that rely on celestial landmarks, highlighting the importance of this celestial event. The enigmatic behavior of Polaris underscores the need for deeper studies and dedicated research efforts. Astronomers must grapple with the complexities surrounding its irregular pulsations and provide concrete answers. Recognizing the importance of advancing our understanding of stellar complexities is crucial. Ultimately, the true fate of Polaris remains uncertain, and only time will reveal its final nature. However, the pursuit of knowledge and understanding in the face of cosmic uncertainty is a testament to humanity's enduring curiosity about unraveling the mysteries of the universe. The implications of Polaris's potential transformation extend beyond mere astronomical interest. They relate to the very fabric of how humanity understands its place in the universe. Throughout history, celestial bodies have served as markers of time and navigation, guiding travelers across uncharted waters and lands. The loss of Polaris wouldn't just disrupt traditional navigation methods but could also have profound consequences for cultural mythology and symbolism tied to the North Star in various societies. Polaris has been central to folklore and spirituality in many cultures. For instance, Native American tribes often saw Polaris as a guiding light in their stories, symbolizing hope and perseverance. Similarly, ancient Egyptians used the North Star in their architectural designs, aligning pyramids to its position in the sky. The disappearance of such a vital star could alter cultural narratives and the collective human experience related to navigation and orientation. Moreover, the scientific community stands to face significant challenges if Polaris were to vanish. Many astronomical measurements and observations rely heavily on established reference points. Polaris's role as a constant has facilitated the calibration of instruments and models used to study distant galaxies, star formations, and even the expansion of the universe. Its sudden absence would require recalibrating many of these systems, potentially leading to discrepancies in measurements and interpretations of cosmic phenomena. As astronomers shift their focus to monitoring Polaris more closely, new observational technologies are being developed. Advances in spectroscopy and photometry allow scientists to analyze the light emitted by stars in unprecedented detail. These tools are crucial for detecting minute changes in brightness, which are essential for understanding the mechanisms driving stellar behavior. As researchers gather more data, they hope to refine their models of stellar evolution, particularly for stars in the later stages of their life cycles. The study of other similar stars, such as Cepheids and red giants, offers insights that may prove valuable in understanding Polaris. For example, astronomers are examining factors like the period-luminosity relationship, which helps measure distances across the universe. By comparing the behavior of these stars to that of Polaris, Scientists aim to gain a clearer understanding of stellar dynamics and evolution, enhancing their understanding of our galaxy's structure. Furthermore, as the search for exoplanets intensifies, the study of Polaris and its companions becomes increasingly significant. Understanding the characteristics of stars in triple systems can provide vital insights into the formation and habitability of planets orbiting them. Astronomers are keenly interested in how such stars influence their surroundings, potentially affecting the conditions under which planets form and evolve. If Polaris undergoes a significant event, such as a pulsation leading to its transformation, it could serve as a stellar laboratory for studying the life cycles of stars. Such occurrences would not only provide a window into stellar death but could also illuminate aspects of nucleosynthesis, the process by which elements are formed in stars. The remnants of Polaris could contribute to the interstellar medium, enriching it with heavy elements essential for the formation of new stars and planets.